Here we have an exponential equation and we have to solve for x in the given exponential equation. Okay, so before I do the first step in this problem, so what I'm going to do is I'm going to consider the product rule of exponents. That is, I multiply two terms with the same base, that is a to the mth power times a to the nth power. So whenever I multiply two terms with the same base, what I need to do is I have to take the base ones and I have to add the exponents, that is m positive n. Okay, now let's think about this product of exponent in reverse order. That is, we have base a on the right side and we have two values are added at the exponent. So whenever two values are added at the exponent, so we have to take this base a separately for each value over here and we have to multiply the two powers, a to the mth power and a to the nth power. Okay, now I'm going to use this product of exponent over here in reverse order. So because we have two values are added at the exponent, x and 1. So what I'm going to do is I'm going to take this base 5 separately for this x and 1 and I have to multiply the two powers, that is 5 to the xth power times 5 to the first power. Actually, the value of 5 to the first power is just 5. So we can simply write just 5 over here. Negative 5 to the xth power equals to 100. Now, the greatest common divisor for these two terms is 5 to the xth power because I find 5 to the xth power in both the terms. So 5 to the xth power can be factored out. If I factor 5 to the xth power out, then I'm getting 5 negative 1 inside the parenthesis. Okay, since 5 to the xth power is factored out, to get the stuff inside the parenthesis, usually what we have to do is we have to divide each of these two terms by the one I factored out. If I divide this one by the one I factored 5 to the xth power, I'm just getting 5. So I'm writing the 5 over here. If I divide this one by the one I factor, that is 5 to the xth power, I'm getting negative 1. So equals to 100. So we can verify the factoring what we have done over here. So when I distribute this 5 to the xth power to this 5, then I'm getting 5 to the xth power times 5. When I distribute this 5 to the xth power to this negative 1, I'm getting negative 5 to the xth power. Okay, now 5 to the xth power times, when I simplify this one, I'm just getting 4 equals to 100. Okay, now I divide both sides by 4. When I divide both sides by 4, this 4 will cancel out. I'm getting 5 to the xth power equals to the simplification of this one. This 100 over 4 is equal to 25. Okay, now, so we have to solve for x of that we have at the exponent. So whenever I want to solve for a variable that is at the exponent, I need to get the same base on both sides of the equation. So here we have base 5 on the left side. So on the right side also we should be getting a base, we should be trying to get base. So actually 25 is a power of 5, so it can be written so as 5 square, that is 5 to the xth power equals to 5 to the second power. Okay, here we can consider the one-to-one property of exponential equation. That is, so whenever two terms are equal with the same base, what we can do is we can equate the exponents. So when I equate the exponents, I'm getting x equals to 2. So I have solved for x and the given exponential equation. The value of x is 2.